We all know how to count from 0 to 9, but what about from A to F? Have you ever seen or imagined using letters to count? Well, we don't use them to count in our day-to-day lives, but computers do. If you tried to learn hexadecimals but couldn't find a comprehensible explanation, in this video I will explain what it is with real-life examples so everyone, even you, can understand it. So stay tuned. Hexadecimal is another numbering system that is used in computers not to make computers' job easy, but our job easy, because we don't have time to memorize the binary numbers for every single decimal number. And more importantly, we don't want to mess up counting binary. Imagine counting 11110011 to someone, and instead of saying 41, saying fewer or more ones, or the other person gets it wrong. That would mess everything up, and that would give us a headache to double check each and every digit to make sure to get it right. That's why hexadecimal was invented, to make our job easier. And instead of saying 11110011, we can simply say F3. Isn't that easier and more headache relieving? We will also use the box analogy that we used in our previous video explaining binary. Hexadecimal is a Latin word, and it's composed of two words. Hex means 6 and decimal means 10. So hex plus decimal means 16, and that's why hexadecimal is a 16-based numbering system. Because it has the word decimal, it means that it uses the same numbers as in decimals, from 0 to 9. They actually mean what they mean. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the 10 numbers. How do we get the remaining 5 numbers? For the remaining 5 numbers, it's not going to use 10, 11, 12, but it will use the letters. That is correct, letters, from A to F, which means A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So all the 16 numbers are going to be from 0 to 9 and from A to F. What do we do after we hit F? We bring another box and put number 1 in it and reset the first box. Wait, isn't that number 10 from decimals? Yeah, it looks like it, but it doesn't mean the decimal 10. It means 17. Wait, what? Are you serious? Yeah, I'm serious. Then how the hell would I know if 10 is the decimal 10 or hexadecimal 10 then? Anytime you see 0x with a number, it gives it out that it's hexadecimal. For example, 0x10 or 0x11 means 17 and 18 in decimal. I will show you how to count and convert decimals to hexadecimals and vice versa later in this video. If you remember from the binary video, I said that a byte is 8 bits. Now how do we use hexadecimals to represent the 8 bits? Pretty simple. One hexadecimal number represents 4 bits of binary, which means we need 2 hexadecimal numbers to represent 1 byte. So instead of these binary numbers, we can simply write B6, D3, 6E. Each pair represents 1 byte. Which one do you think is easier to work with? Obviously, it's going to be the hexadecimal version. Now, where do we see hexadecimal? Where do we use them? If you're dealing with technology, you will in some way or another encounter hexadecimal numbers. Few places are color code, which in this case, this numbers means green. MAC addresses, IPv6 addresses, error codes, and many more. I personally haven't had to deal with interpreting the hexadecimal numbers yet, except for in MAC addresses. If you know any field that has to convert back and forth the hexadecimal with decimals, I would love to know about them. Now let's get into how to count and convert hexadecimals and decimals. Let's have a flashback to these two numbering systems. Do you see a pattern between each number? You guessed right. In decimals, each number is multiplied by 10. In binary, each number is multiplied by 2. Let me ask you this. By what number do we multiply each number in hexadecimal system? That's correct, 16, because it's a 16-based numbering system. Let's use the box analogy again to see how to count in hexadecimal. This time, our box can hold 16 numbers, 0 to 9, and A to F. When we reach F, we added another box and set it to 1. What value would the right box get? 0 to give us 10 for 17 in decimal, 18, 19, 20, 21, all the way to 32. Then we set the left box to 2 and start counting again. Hope that made sense. That was how to count in hexadecimals. What about converting from decimals to hexadecimals and vice versa? For converting a decimal number to hexadecimal number, there are two ways to do it. Either with a pen and paper, that would be quicker. For me, it's quicker. Or using a calculator that would require you to perform two operations. Let me show you how the first method is used. I'm given the number decimal 42. On paper, I try to simplify it as simple as possible. So 42 divided by 16 would give me 2 as the quotient and 10 as the remainder. Why did I divide it by 16? Because hexadecimal is a 16-base numbering system. Can I divide it further? No, because 16 is larger than the remainder. We save the quotient and convert the remainder to its hexadecimal character, which is A. Then we put both next to each other and we get the hexadecimal value of number 42. Personally, this is my preferred way to do it. It's pretty straightforward and quick. The next method is to use a calculator. In this method, I need to divide the number by 16 as well as its modulo by 16. If you don't know what modulo is, it gives you the remainder of a division. You see, when you divide a number, it gives you the quotient, while modulo gives you the remainder. Your calculator might have a button for it. Look for MOD. Now 42 divided by 16 is 2.625. Don't worry about the decimal, just take 2. Now type 42 mod 16 and it will give you 10. Convert it to hexadecimal and put it beside 2 for 2a. These were the two methods of conversion from decimal to hexadecimal. Let me know in the comment which one works best for you. To convert a hexadecimal to a decimal, I want to take you back to binary and decimal first. We said that in order to add a box to the left side of the number, we multiply the number by 10 for decimal and 2 for binary. I want to do the same thing with hexadecimal. So 1 times 16 is 16, 16 times 16 is 256, and 256 times 16 is 4096. To convert a hexadecimal, in this case 4D to a decimal, I split the number into two parts. I put the first number under 1 and the second number under 16, then I multiply them. 13 times 1 is 13, and 4 times 16 is 64. Then I add them up to get 77. Where did I get 13 from? I converted D to its decimal value. Now to do this process quicker, let's say we have 5D, just multiply 5 by 16 and find the decimal version of F and add them up. No need to draw the table. To wrap things up, we covered what hexadecimals are, how they are represented, how to count in hexadecimal, and how to convert between hexadecimal and decimal. That was everything you need to get started with hexadecimal. There's always more to learn, but this foundation will take you far. If you found this helpful, don't forget to share the video with friends and family. See you next time.